Dear students, in this particular topic we are going to learn more about extension to Keras, wherein how can we create and configure a model, how do we train, test, save and load a particular model. So let us go ahead and look at it. So if I want to really create a particular model, then I have to import the necessary libraries as well as the modules from Keras. So first I define the model architecture, including the number of layers, what type of layers, activation functions and the shapes of inputs and outputs. So you can see here I am calling a sequential container. So I am going for a dynamic declaration here. That's why my model name is an empty container here, and I'm going to import my fully connected layer. So that's how I'm calling a dense layer. So once I have imported these from Keras, the model, the container as well as my layer, I am going to build an empty container, and I'm explicitly going to add what all layers that I want. So as you can see here, I am first giving an input layer with units of 64 with an activation function of ReLU and some input dimensions, and at the end I'm just it's a very simple type of an explanation that I am giving. That's the reason after an input I'm defining an output. So the number of classes will be my units and the activation function is softmax. So suppose if it is a multi-category classification, I will go for a softmax activation function. So this is how you can create a particular model very easily by knowing the importance of sequential container and the layers that you can call from Keras. Now after that, you can compile a particular model for which you need to configure its learning process. You have to specify what type of optimizer you want. There are different types of optimizers that are available, like stochastic gradient descent, like you have ADAM, you have ADAGRAD. So based on the type of application that you're choosing, choose your optimizer. The better here if you're using is an ADAM optimizer. It has got its own momentum at which you can come to the minimum point of your gradient. So ADAM is the optimizer that I have chosen here, and the loss function, again I already taught you, if you are going for certain mathematical calculations of regressions, you go for MSE. You can also go for MAE, mean absolute error loss function, or if you are going for classification, then please go for cross entropy loss function. So here I am choosing categorical cross entropy, and the evaluation metric that I am choosing here is an accuracy of the particular model, and I want to compile my model based on its defined optimizer loss function and evaluation metrics. I hope this is clear. So once I have compiled the model, I have to go for my data preparation. You have to, this is something which you are not new with. You have to create your own training data and test data by, loading your data set, by pre-processing your data set. Already you have learned all these things in your machine learning part. So here you pre-process the data, you load and pre-process your data and split it into the training and testing data with the input features as well as the target, which is your label data set. So using your machine learning knowledge, you can use it using sklearn model selection, and you will import train test split, and you can work on it. I think this is okay for you. Now next is you have to train your model. So in order to train your model, whatever sequential container you have defined, so you remember I gave the name here as model to my sequential container. So what I am doing here is, once I have compiled my model, I am going to fit my model. So now fitting your model will actually make the model train. So train the model using the fit method. You pass in your training data like features and labels. You are going to give your, you can see here I have passed on my model.fit method with my training data and training labels, number of epochs I have to specify for which iterations you are going to do. If it is batch size gradient descent, I have to specify how much is the batch size of the training data that I am supposed to use. If at all I am using any validation data set, then I am going to use an X test and a Y test. Okay, so with this you will be training your model, and if at all needed, give your validation data and give your training data, give the number of epochs, give the batch size. So after you have done with your fitting of your model, that is your training of your model, what you are going to go for is evaluate that particular model. So how do you evaluate that particular model? Based on the test data set. right? So for that you are supposed to perform model.evaluate and give the parameters as x test and y test and check for whatever is the loss function and what is the test accuracy. So this particular step is very important to understand if at all any overfit condition is prevailing. So you all know that if training accuracy is high and testing accuracy is low, then it is an overfit model, right? So after you evaluate this model, if you get test accuracy down, then you can again go back to your sequential network and you can increase or decrease the number of layers based on whether the model is overfit or underfit. It gives a kind of adaptability to your model without rewriting entire code again and again. So simply go change your settings in your sequential container and you're good to go. Okay, so once you are done with evaluation of your model, you can go for prediction of a model, wherein you use the trained model to make prediction on any new data or any unseen data, and you get your predictions out of it. So a very simple technique that I am showing here is to save and load the model. Now there are three methods for it. The first method is tensor method. So tensor method is the same method that I have just explained you. You are going to call a simple, so you are going to create a simple sequential model. You will compile the model, train the model. You will simply save this particular model by using tf.saved save model method. Tf model.save is what you are going to use it. So that's a simple using TensorFlow. Now how will you load this particular model? Using model.load method. Okay, and once you save the model, you can call it anytime, you can load it, and then you can make your predictions. Okay, so this is how tensor method works. Now the next one is network method. So let me introduce you a method which will not require any network source files. It will only need the parameter file. So for that, model structure and model parameters have to be saved to the path file with the help of model.savePath function. And the network structure and network parameters can be restored through load model. You will see a simple example here. First, suppose if I am working with an MNIST handwritten digital picture recognition model. So I save that particular model to a file and then I delete the network object. So you can see here what I am doing. I am saving the network.save model.h5, right? And I am deleting this particular network. Now after this, the structure and the state of the network can be recovered through this model.h5 file. There is no need to create this network object again. So what I am going to do here is I recover the model and the parameters from a file from load underscore model method, and I simply give model.h5 whatever I have saved the network as. So in addition to storing the model parameters, this particular file should also save the network structure information. So simply passing this, you can again load load this particular model. That's the second method. The third method is using saved model method. So this particular method is used when you are working with multiple platforms. Okay, because this particular save model method is proposed by TensorFlow and it is actually platform independent. So when you are working with different platforms together, you can actually save your model and load using this particular method. So what I am doing in this method, I am saving the model and parameters to a particular file using saved underscore model dot save, and this is given by TensorFlow. That's why tf dot saved underscore model dot save, and I'm going to save my network and parameters, model and parameters to a particular file. So I saved it and then I deleted the network object. Once I have done that, I'll recover the network parameter from the file. What is the name that I have saved as? Model hyphen saved model. So I am loading here using saved underscore model method, model hyphen saved model. Once I done that, I want to calculate the metrics. I am doing a loop through test data set and then a forward calculation, and it gives me whatever the value. So basic thing is, how do you save and load a particular model using a saved model method? So there are three ways in which you can save and load a model. One is a TensorFlow method that you have just seen. This is tensor method, saving and loading using tensor method. Second one is a network method. This is the way where you will save all the model and parameters to a particular file. And then this is your saved model method. This is used when you are working with multiple platforms. So this was about creating, configuring, training, testing, saving, and loading of various models using Keras. So we'll see you in our next class.